Hi, my name is Grace Lee, and in this summer, I analyzed species diversity and the influences of life history variation, annuals versus perennials, employee variation, polyploids versus diploids, on niche breast, the adaptability to heterogeneous environments in Trifolium section Involucrarium species. We hypothesized that annuals have wider niche breadth and are tolerant over a wider range of environmental conditions than perennials. We also hypothesized that polyploids have wider niche breadths than diploids. We hypothesized that annuals have wider niche breadths because they could complete their life cycles quickly and escape harsh times through seed dormancy. In contrast, perennials need to invest energy for storage and survival through harsh times, but they have resource advantages at the beginning of the growing season. We hypothesized that polyploids have wider niche breadths than diploids because the doubling of genomes may provide polyploids genetic variation, conferring them with flexibility to a wider range of environments. This is seen in the well-known allopolyploid Trifolium repens. The current study system, Trifolium section Involucrarium, is very diverse, located all throughout North America. It has a known phylogeny showing evolution in life history from perennial to annual and evolution in ploidy from diploid to polyploid. We tested our hypotheses by extracting the values of 35 bioclimatic covariates based on species occurrences. We determined the PCs and the top contributing variables to each PC. We estimated niche breadth as a standard deviation of values along each PC after resampling the niche space 1,000 times. Clades N and K show life history variation. In clade N, Trifolium solaniferum, the perennial, displays niche contraction relative to the other annuals along both PCs, and also a slightly lower mean temperature of the coldest quarter than the annual Trifolium reflexum. In clade K, there is no consistent pattern in niche breadth between PC1 and PC2. Perennials have a wider niche breadth along PC1, but a narrower niche breadth along PC2. In addition, perennials show lower growing degrees days than annuals. Clades Q and P show ploidy variation. In clade Q, polyploids have wider niche breadths than diploids, especially along PC1. Polyploids occur in regions with wider variability in temperature and moisture than diploids. In clade P, the polyploid Trifolium peri has an intermediate niche breadth compared to the diploids, with also lower values of temperature. Overall, the trends in niche breadth with regard to life history and ploidy variation are inconsistent among clades in section Involucrarium. Life history and ploidy may not be the only factors that affect niche breadth. Future analyses will consider other factors such as plant functional traits, and also look at other niche variables besides bioclimatic ones in PCA analysis in order to get a full understanding of niche breadth. This is essential for identifying the species at greatest risk of extinction due to climate change to preserve species diversity. Thank you so much for listening. If you would like to learn more, please refer to my poster for more details. Feel free to comment or email me with any questions.